All right, pre-calc, we are continuing on with 7.2, and in a normal school year, we might spend some time just exploring the 12 graphs that are on the next page and just examining some of the similarities between the equations and the graphs. Well, because this is a video and kind of not really any reason to have you examine on your own, it actually just makes sense to jump to what you're supposed to notice. And you don't have to actually use a color, with crayons or shading or anything like that. But the whole premise is to look at the graph and see that if you are going up and to the right, that is growth. And we've talked about increasing functions. So as you look through, go ahead and label which ones are increasing. So growth, decreasing is decay. I'm sure you've heard of phrases like that. Exponential decay, exponential growth, exponential decay, growth, growth, growth. And that's the other thing, is we can reflect over the x-axis. That's perfectly fine. And we still would consider this growth because it's going up and to the right. It's increasing. And I know some students would, I don't know if you would actually disagree with that, but we care about it increasing. We care about f increasing there. So there's the rest of those. So if I go back, feel free to copy these problems down as you wish, but I'm not going to collect your notes. I think you guys know that about me. If we had a in-class time, we could talk about this. But instead, kind of want to just get you to understand what we're looking for. So in this problem, the base is only what's being taken to the power. So as we examine the different values, the value of a in this problem would be a 1. The base would be 3/2. The c value in this problem, what we want to do is consider that the exponent is set equal to 0. We've done this earlier in the year. When we did the argument was set equal to 0. So as we subtract 2 over, most people would probably just add x over, but I'm going to do this sort of the long way and divide by -1, get x equals 2. So that would be my c value, and then the d value in this case would be -2. So as you examine what type of reflections this has, because the negative was with the x value, if you think back to earlier in the year, this is a reflection over the y-axis. Remember, if you have negative x values, you reflect over the y-axis. So as I move on, notice that the parentheses matter. So if you follow the order of operations, you do the exponent before this negative. So what that means is that the a value is -1. You could think of rewriting this problem as -1 times 3 to the x minus 1 power, and then -2. So then that base is 3, positive 3. And then most people would look at that and be able to tell that x equals 1, but if I follow the same rule as number 1, I want to set the argument equal to 0 and then add 1 over. And then in this case, the d value is positive 2. And this one also has a reflection. But when the a value is negative, that's going to reflect over the x-axis. All right, so I think we've done enough where you could probably follow through pretty quickly. You could probably even hit pause in the video and see if you get the same answers. X equals 1, but again, if you set the argument equal to 0, you could solve for that one, and this d value would be -2. This one does not have any reflections. Same thing with this one, -1, your base would be 2/3. This time we do have a reflection. Actually, there's 2 reflections, but let's go ahead and solve this first. Set the argument equal to 0. Again, I'd probably just add x to the right side to get x equals 2, but you can work through it any other way you want. The d value would be 3. This has an x and a y-axis reflection. And then this one, the a value would be -3. Your base is 1/2. the C value would be -1. I know I keep writing X here, it's just out of habit. And if you write C, I know exactly what you mean, or you can write as X equals like I have. And then on this one we do have, because the A value is negative, it's going to reflect over the X axis. There you go. And just to double check that you have everything copied down correctly, here's the answer key. And feel free to examine these graphs a little bit more. You can type these into your graphing calculator, into y equals, and see, do we have exponential growth? Do we have exponential decay? What's going on between the different values here, as well as rules we've established earlier in the year. Like what makes it a y-axis reflection? What makes this an x-axis reflection? What do you think the d value is doing in these exponential functions? And if you need any clues, you can look at some of these problems. You could be looking at the d value and seeing how, -1, I wonder if that's always the horizontal asymptote. -2, I wonder if that's always the horizontal asymptote. Things like that. So go ahead and pause and think about that. While I know the next page is to tell you about the answers. So these are rules that we are going to establish, and we're going to get a lot of practice with it. So it might take some time, but I hope you get this. Is you may remember from earlier in the year, maybe even Algebra 2, that if your A value was negative, that flipped over the x-axis and made the graph be below the horizontal asymptote. Below the horizontal asymptote if the A value was negative. So if that A value is positive, there's no reflecting over the x-axis, so it's above the horizontal asymptote. What about the D value? Kind of already gave that to you. Well, it is the horizontal asymptote. So these last two rules I would just say it shifts up and down, because if you have a negative D value, your horizontal asymptote is going to be shifted down. So your horizontal asymptote will be below the x-axis. And if your D value is positive, that's going to shift up. So your horizontal asymptote will be above the x-axis. And if there is no D value, if there's no plus number over here, then the horizontal asymptote would be the x-axis. And hopefully all of that makes sense. If not, play around with the calculator. See what happens. Which I know I'm just sharing with you the answer key. Yeah, let's go ahead and talk about the next thing. So, we're going back a few pages. I'm not sure if the page number is corresponding to what I want it to. Sorry if you're following along. It's actually page 409. I always do that. I always delete a page or add a page, and that messes things up. So I forgot to change that. So in number 1 from that function, it's asking if it's increasing or decreasing. Okay? And we always read the graph left to right, so that's a redundant statement. So as we go back to that problem, it's increasing. So that was exponential growth. So what they're trying to get you increasing, that is growth. And what they're trying to get you to recognize is a couple things. Do we have 0, 1, or 2 reflections? Well, if you go back to that equation, there's no negative in front. There's no negative up here, so there's no reflections. So there are 0 reflections. I'd rather label them out, like list them out, than saying just X or Y. I would say that there's 0 reflections. And also, the base, if we go back to it, is 2. And what we care about is that, the base is equal to 2. So that means the base is bigger than 1. So what I need you to do is kind of go through the chart and answer these questions and see if you can come up with a rule. So I'll do number 2 as well. It's going down. It's decreasing to the right, making that decay. If it's increasing, it's growth. If it's decreasing, it's decay. If we go back to that problem, there's no negative in front. There's no negative in front of the x, so there are 0 reflections. And if you looked at the base, which is 1/2, the base is smaller than 1, but also bigger than 0. I didn't mention it, so I'll say it right now, is the base can never equal 1. If the base is 1, well, 1 to any power is 1, so it's actually a horizontal line. So that's why we only consider positive numbers, and we do not consider 1. So go ahead and work through some of the remaining of them, and I'll share with you the chart, and then I'll share with you what you're supposed to learn. So investigate a little bit, but if you don't want to investigate on your own, you just want the answers, just keep watching. So as I'm looking through this, the first one with any reflections occurs at number 7 because there's a negative right here. There's 1 reflection. Number 8, there's a negative right here. That's 1 reflection. Number 9, a negative right here. There's 1 reflection. Number 10 has 1 reflection. 11 has 1 reflection. And 12 has 1 reflection. So you're looking at where the negatives occur, either in front or in the exponent. So like I said, I'm going to show the answer key. So we already did 1 and 2 together. So here would be 3 through 8. Hit pause if you're still writing anything. And then here's the rest of them. And the reason why I care about how many reflections is, well, what would happen if we had an x and a y-axis reflection? Do you think something would happen? So go ahead and hit pause if you still need to write anything down. But the whole premise of this lesson is to get you to recognize these 4 rules. And I'm well aware that this is the beginning of the notes for section 3. Notice that there's no homework for section 2, but I need you to watch the video to kind of investigate on your own. And if this were a normal school year, I would have we would be doing section 2 in class, getting you to investigate. As if you notice, I really haven't walked you through much. I've told you to pause the video and try something on your own, but I'm not assigning anything out of that. So you can hit pause if you want to get these notes written down before I end this video. This is where we're going to go for section 3. We have 4 scenarios on 2 for growth, 2 on decay, and as I mentioned before, we need to consider if we have 2 reflections, as I kind of have warned you about. So I'm ending the video here, and I'll see you in section 3.